Antimatter is a captivating concept in particle physics, representing a form of matter that is almost identical to ordinary matter but with opposite electrical charge. This intriguing phenomenon has fascinated scientists and captured the imagination of science enthusiasts for decades. In the incredible world of antimatter, particles such as antiprotons, antineutrons, and positrons exist as counterparts to protons, neutrons, and electrons, respectively. These particles possess the same mass as their matter counterparts but carry opposite charges. When matter and antimatter particles come into contact, they annihilate each other, releasing a tremendous amount of energy. Certainly. Here are some additional details to expand on the incredible world of antimatter, a particle with opposite properties. 1. Antimatter production. Antimatter can be produced through high-energy particle collisions or nuclear reactions. Particle accelerators, such as the Large Hadron Collider, LHC, play a crucial role in generating antimatter for experimental purposes. 2. Antimatter in space. Antimatter particles have been observed in space, particularly in cosmic rays and in certain astrophysical events, such as gamma-ray bursts. Scientists are studying these phenomena to gain insights into the origin and nature of antimatter in the universe. 3. Challenges in antimatter research. Antimatter poses unique challenges for scientists due to its limited availability and difficulties in storage and containment. The production and storage of antimatter require highly specialized facilities and techniques to prevent it from coming into contact with regular matter. 4. Theoretical applications. Antimatter has captivated the imagination of science fiction writers and has been portrayed as a powerful energy source or even as a fuel for interstellar travel. While these concepts are still speculative, ongoing research explores the potential applications of antimatter in propulsion systems and energy generation. 5. Antimatter and the universe's antimatter-matter imbalance. The question of why the universe is predominantly made up of matter while antimatter seems to be scarce is known as the matter-antimatter asymmetry problem. Scientists continue to investigate this mystery through experiments and theoretical models to better understand the fundamental nature of the universe. 6. Antimatter annihilation. When matter and antimatter come into contact, they annihilate each other, releasing an enormous amount of energy. This process, known as antimatter annihilation, is highly efficient and produces pure energy without any harmful byproducts. Scientists are exploring ways to harness this energy for potential future applications. 7. Medical and industrial uses. Antimatter has practical applications beyond scientific research. Positron emission tomography, PET, scanners in medical imaging use positrons, the antiparticles of electrons, to create detailed images of the human body. Antimatter is also used in industrial processes, such as material testing and the detection of flaws in industrial equipment. 8. Antimatter as a probe. Scientists use antimatter particles, such as positrons and antiprotons, as probes to study the properties of matter at a fundamental level. By colliding these particles with regular matter, researchers can gain insights into the structure of atoms, the behavior of subatomic particles, and the nature of forces governing the universe. 9. Challenges in antimatter storage. Antimatter is notoriously difficult to store due to its interactions with matter. It requires sophisticated containment systems that involve electromagnetic fields and powerful magnetic traps to prevent contact with ordinary matter. Scientists are continually improving techniques to trap and manipulate antimatter for extended periods. 10. Antimatter and fundamental physics. The study of antimatter plays a crucial role in advancing our understanding of fundamental physics. It helps to test the symmetry and conservation laws that govern the behavior of particles and forces. Antimatter experiments provide insights into topics such as particle decay, particle-antiparticle interactions, and the properties of the weak and strong nuclear forces. The incredible world of antimatter, a particle with opposite properties, takes you on a journey into the mysterious realm of antimatter, shedding light on its creation, detection, and potential future applications. Join us as we explore the cutting-edge research and delve into the profound implications of this enigmatic particle for our understanding of the cosmos.